So in this calculation, we have to evaluate 1 minus 2i divided by 2 minus 3i. The idea behind this rationalization of complex numbers is that if somebody gives you a complex number by 2 minus 3i, for example, you'll always find that the 2 minus 3i by its complex conjugate, which is 2 minus 3i complex conjugate, is always equal to the magnitude of 2 minus 3i squared. We actually see this calculation as the following. So whenever you have a complex number, its complex conjugate, right, you'll always find it's equal to the magnitude of the complex number squared. In this case, this will be 2 squared plus 3 squared. So that would be 2 squared plus 3 squared. In this case is 9 plus 4, 13. So any complex number can always be calculated like this. So when we have a division of two complex numbers, we can multiply by 1 the complex conjugate of the denominator. So this would be 1 minus 2i over 2 minus 3i multiplied by 2 plus 3i, which is the complex conjugate. So notice that 2 plus 3i is the complex conjugate of 2 minus 3i. And so we know the product of 2 plus 3i is going to be the magnitude squared. So this is 1 minus 2i times 2 plus 3i, all divisible by the magnitude of 2 minus 3i squared. In this case, it happens to be 13. We just calculated it. So we can just do a regular expansion. 1 minus 2i times 2 plus 3i. So this is 1 minus times 2 plus 3i minus 2i times 2 plus 3i. So this is 2 plus 3i minus 2i times 2 is minus 4i. Minus 2 is minus 6i squared. And I guess I'll continue this problem over here. Is there enough space? Yeah, there's enough space. So we're left with, so far, we have 1 over 13, 2 plus 3i, minus 4i, minus 6i squared. Notice that I squared is equal to minus 1, so we can convert this to minus 1. So this becomes 1 over 13, 2 plus 3i minus 4i minus 6 times minus 1. So I'm going to put all the terms together, so there's a real number here and there's a complex portion here. So this becomes 1 over 13, 2 plus 6 is 8. 3i minus 4i is minus I. So we get the answer 8 over 13 minus 1 over 13i.